Welcome everyone. So what we're going to be talking about today is Dalton and Dalton's law of partial pressures. And so this is a very, very basic idea. It is so simple. And so we're going to do a few different problems with Dalton's law that some may get to be not necessarily difficult, just longer problems, but nothing that's really difficult or hard to understand. The main idea of what Dalton's law says is this. If you have two separate gases, and you know the pressure of each one, and you mix those gases together, if you take the pressure of the first one and the pressure of the second one, all you have to do to get the total pressure is add them together. That's all that Dalton's law states. So if you mix the two gases and each one has a certain pressure, then you just simply add. That's all it says. And you could have 3 gases, you could have 4 gases, you could have 6 gases. All right, so let's start this off. It says Dalton's law of partial pressure. Partial pressure is simply what it sounds like. It's the contribution that each gas in a mixture makes to your total. So how much does each gas contribute to the total in pressure, okay, in pressure units? Dalton's law of partial pressure states at constant volume and temperature, the total pressure is simply the sum of all of them. In other words, your total pressure is equal to P1 plus P2 plus P3 plus ... until you get to Pn. That's basically what they say. So just add them all up together. So if you have a situation where you are given, like we were working on this Dalton's law worksheet, and it's all given to you in pressure units. Now you can use kilopascals, you can use atmospheres. We also use millimeters of mercury, which you could also call what? Do you remember what those are also called? Torr. They're also called torr. You can use any of those, and as long as you're given the pressure of the gas, you can again either add to equal the total, or maybe they give you the total and they're asking you for one of them when they're giving you a couple of the pressures, okay? And those are really easy. So like in this example, we added to get the total, and in this one they gave us the total, so we subtracted to get what in this case was the partial pressure of the nitrogen. And those are pretty easy to do, okay? So now let's take a look and see what happens if you're not actually given partial pressures. What happens if instead you're given grams? What happens if instead you're given a percentage? What happens if instead you're given moles? Then how are you supposed to calculate it? Because it is correct to do that, to say I have so many moles of nitrogen gas, or I have so many moles of oxygen gas. Then how does that work, or how many, or if you have grams of it? So that's what we're going to do, is we're going to change it up just a tiny bit to see how that calculation ends up being different. Okay, still going to be the same idea though. Gas pressure basically depends on 2 things. Okay. So if you had a balloon and you wanted to know what the pressure was, you need to know what about the inside of the balloon. 2 major things that are going to affect gas pressure. One is just how many what? How many molecules, how many particles you have. So one is simply the number of particles that you have inside of there. In your given volume, how many particles do you have? And the second thing that can also change what your gas pressure is, starts with a T, is temperature. Awesome. The other thing is your temperature is also going to make a difference. The particles in a gas mixture at the same temperature, we talked about this. This is probably the 10th time that we've said it in the year, in the notes, is the same average what? If your temperature's the same, what's the same?
Kinetic energy.
Awesome. The average kinetic energy. Very good. Okay? So as you increase your temperature, then you're also going to increase your KE average. Okay? Those are going to be directly related to each other. If you know the pressure exerted by each gas in a mixture, then all you have to do is add up to get the total. Perfect. All you're going to do is you're going to add up, and that's going to give you your total pressure. So we already know that. A large misconception that people have is that air is mainly composed of oxygen. Remember, it's not. Air is not mainly composed of oxygen. What is air mostly made of?
Nitrogen.
Nitrogen. And about how much? Roughly, just throw out a percentage. Roughly what?
70, 80.
70, 80. Perfect. The number we're going to use just for calculation-wise, I'm going to go out more sig figs. So 78.08% nitrogen. Okay, 78.08% nitrogen. So then oxygen can't really be any more than 22%, right? So what do you think oxygen is? 21? It's 20.95% oxygen. Now CO2, we've spoken a lot about that in the past years because of it's one of those greenhouse gases, but the percentage of it is actually very, very, very small. It's only, anybody want to guess? it's even less than 0.6. It's actually only 0.04%. It's only 0.04% in air, but it still has a big effect on the environment. Argon and others, what that leaves us with is 93.93% is argon, and anything else is 0.93%. Okay, so now the question is, how are these questions going to be different? We're not being given pressures now, so I'm going to change it up so that we're not being given pressures. So how do we solve a problem? It says sea level is based on an average of the elevation of the oceans around the world through an averaging out of the heights. If the total atmospheric pressure at sea level is 760, so what I'm going to do is, because they're telling us this is the total, I'm going to write this as P subscript TOT for total. So that's P tot or P total. And so they're giving us the total pressure, and it says, what are the partial pressures of each of the components of air in torr? Well, torr is the same thing as what? Millimeters of mercury. So do I have to convert anything?
No.
Nope, no conversions. That's the same unit as this one, okay? And so we know that that's what we call atmospheric pressure is 760, okay, at sea level. So what we need to do here is we need to figure out, we know the percentages of each one of these, but we want to know what the partial pressure is of each one. So how do you do that? If you know the percent of each one and you know the total, what do you do to those two numbers to figure it out? Multiply! Awesome! But you can't multiply by the percent in your calculator. What do you have to do to the percent first? Shift your decimal 2 loops back. Now, when you do that, it's no longer called a percent. Starts with an F now. What is that called
Fraction.
now? A fraction. So that's called a fraction now, okay? And I'll tell you what specifically that's called. It's actually called the mole fraction is what that's called. Okay, and we'll talk about that in a second. We'll get the equation down. So the first thing is, I want you to write P, and then it's a subscript N2. Okay, even though I kind of write it a little bit bigger, it's supposed to be a subscript N2. So this is finding the partial pressure of the nitrogen. So all we're going to do is we're going to shift our decimal 2 loops back, and so we get 0.7808, and we're going to multiply that by the total pressure, which they tell us is 760 millimeters of mercury. So when we do this, we end up getting 593.4 millimeters. Really, it should be 3 sig figs. I'm just going to use 4 just for the sake of adding to make sure that we get the right answer. So 593.4 millimeters of mercury. Okay, because that has no unit, the fraction has no unit, okay, and so your unit is just going to be whatever the unit is of pressure. So now let's try the PO2. What do we do for the PO2? What number would you use instead of 20.95? You would use 0.2095, bless you, times the 760 again, millimeters of mercury. And when we multiply these two together, again, I know it's supposed to be 3 sig figs. We're going to use 4 just for the sake of adding it, millimeters of mercury. And now we also need the PCO2. PCO2, you don't use 0.04. What do you use? 0.0004. So remember, you have to shift your decimal 2 back. A lot of people will make a mistake on this one because they just use 0.04. So you still have to go 0.0004 times 760. And the very last one, and so this ends up equaling 0.3 because I really do have 1 sig fig. I'm just trying to get to the tens place anyway. And so 0.3 is the answer to that. The last one you could do 2 different ways. One way is we can do it the same way that we're doing these. So I'm just going to say the partial pressure of argon and others. And this is 0.0093 times 760. What else could you have done? Instead of doing it this way, how else could you figure out this last number? Subtract from the total, which is 760. Good, because these should all add up to equal 760. So if you subtract from 760, you can get that. The reason why I like doing it this way is because I want to make sure that I didn't have a calculation error. If I had a calculation error somewhere in there, then it wouldn't add up to 760. So I actually use this as my check, just because we're shifting decimals so much. So this one ends up equaling 7.1 millimeters of mercury. And so when we add this up, we should end up getting what? 760 millimeters of mercury total. Okay, and that's basically our check of this. Okay? So the question is, can we get an equation from what we did? all right? And the equation basically is the partial pressure of X, of some gas, okay, of some gas, is equal to, what we call this is a fraction, okay? We call it a fraction, but it's not a mass fraction. It's actually a mole fraction. They use a Greek letter that they call chi, and so it kind of looks like an X, okay, like a slanted X. So this is called chi, so that's X. All chi is it is called the mole fraction. Okay, that's our mole fraction. So we took our fraction, and what did we multiply our fraction by? What's this? 760, which was representing the total pressure. Perfect. Times P total. Times the total pressure. So if you ever want the partial pressure of a gas, this is the basic thing. Again, if you're given pressures, like you were on that other worksheet that I was showing you, those are easy. If you're given atmospheres of one and atmospheres of another, and they want to know the total atmospheres, that's easy. Or they want to know one when they give you the total and you just have to subtract. But what happens if you're not given pressures? What happens if you're only given the total and you're given moles or you're given grams? So that's what the problems are going to be on the next page here. All right, so let's take a look. This first one is an easy one, okay? So I wanted to throw one of these on, where in this case, it says a gas mixture contains oxygen, nitrogen, and carbon dioxide. So let's say that inside of a balloon, we have O2, we have N2, and we have CO2 all in the balloon. And it says, what's the partial pressure of the CO2 if the total is 32.9? That means that all of this is 32.9 kPa. And then they give you the PO2 is 6.6 and the N2 is 23. Guess what you do? Add and subtract from the total. Perfect. So all we're going to do is, I'm just going to say the partial pressure of CO2 is equal to the total, which is 32.9 kPa. So under it, I'm just going to write P total minus my 6.6 kPa, because that's the oxygen, PO2, minus the 23.0 kPa, because that is my PN2. And now you're just going to subtract, and I believe you get anybody do this? 3.3?
Yeah.
3.3 kPa, and that's what you would call the partial pressure of your nitrogen, okay? So again, that was an easy one. You're given the pressures, and you just have to figure out one when you know the others. It's easy, Dalton's law. Okay. So now what happens if you're given grams or you're given moles? We're going to come back and fill this in just a little bit. Let's try a problem out and see where it takes us, okay? So before we even start this, though, one of the things that we're going to do is we're going to rewrite that equation that we wrote before, because it's going to help us get an idea of where we want to go. And the equation is that the partial pressure of some gas X, okay, some gas X, is equal to chi, which we called the mole fraction, times what?
Oh, the total.
Times the total pressure. Perfect, okay? So if you ever want to know what the partial pressure is of a gas, you're just going to multiply your mole fraction by the total pressure, okay? So let's take a look at this problem. And this is the hardest that it will get, all right? This is the hardest that it will get. It says you collected the products of a chemical reaction, and you found that the mixture contains SO2, it contains 3.6 grams of water, and 1.4 grams of NO. And then they tell you that the total pressure in the flask is 200. So guess what I'm going to write this variable as? P total. Awesome. That's my P total, okay? Mark it as soon as you see it, and then that way you know you don't have to look for it later. What was the partial pressure of each gas? All right. We know that we're looking for P gas. We know we're looking for P gas. Do we know either one of these? What do we know? We know the total pressure. But do we know chi? No, we don't know the mole fraction yet, okay? So again, just so you know, what we did in this problem, just to kind of review this real quick, how did we get the equation? The way we got the equation was we said if we knew the percent or we knew the fraction, we just had to multiply it by the total to get the partial pressure. So we're just using the equation now that we kind of came up with, okay? So in this case here, guess what we first need to do with grams in order to help us? Change to moles. Awesome. So you don't really need to do L charts anymore. Okay, if you want to, you can, but I feel like we're at a point now where you don't have to do the L chart. You can just do the bridge. So let's start this off. Now I'm going to write each one of them down here. So you're going to end up writing kind of small because we will be taking up most of the space going across. So let's start off with the 14.40 grams of the SO2. Throw in a bridge, cross my units opposite. Right under, I'm going to do the 3.60 grams of water, of H2O. Throw in a bridge, cross my units opposite. And then let's do the 1.40 grams of the NO. Throw in a bridge, cross my units opposite. Okay. I know I'm going to moles on each one of these, moles, moles, and moles. All right. So SO2 grams per mole, well, oxygen 16 times 2, so that's 32. Sulfur is another 32.1, so that ends up giving us 64.1 grams for every mole. Okay, again, you can go to the red numbers, you can spend that time getting your answer, but it should be, a lot of you are going to be pretty quick at these now. Okay, let's do the next one. What's water? So a lot of you have water memorized now. 18.0, awesome, 18.0 grams per mole. Do you know nitrogen's molar mass? 14, good, 14, and oxygen is 16, so add those up, what do you get? 30, nice, 30.0 grams per mole. Okay, and it's always for 1 mole. So let's divide these out. So on the first one, we get 0.225, we're going to do 3 sig figs because of the molar mass. So 0.225 moles of the SO2. The second one, when we divide here, 3.60, I lost my decimal on some of these. So on this one we divide, we're going to get 0.200 moles of the H2O. And now the last one, if we do 1.40 divided by 30, we're going to get 0.0467 moles of the NO, of the nitrogen monoxide. All right. We're in moles, but we need a mole fraction. If I asked you, let's say that you ordered some pizza, you got a pizza that was like 10 pieces, and I said, what fraction did you eat? How would you calculate what fraction you ate? How many you ate? So let's say you ate 3 pieces, and then what? Divide by the total. And then, if you want a fraction, you stop there. You're done. If you wanted a percent, what would you do? Multiply by 100. But if you want the fraction, you're done. It would be 3 over 10, for example. Okay, and you could divide it and get a decimal instead. So if I want a mole fraction here, what do I need to do? I can take the moles of each one and divide by what? Total what? Moles. Awesome. What we need is we need to divide by the total moles. Just like if you had pizza, you would say how many pieces of pizza did I eat divided by the total number of pizza. Okay? So you always do x over the total of itself, of the entire thing. So we're going to do that. Well, we need the total of these. So all we're going to do is add these up together. So let's add all 3 of these up. So if we do 0.225 plus 0.2 plus 0.0467, we should get 0.472 moles total as our answer. Okay, so 0.472 moles total. All right, so now we have the total, so we need to divide by the total for each one. So on this one, you can do under if you want to. I'm just going to do it over on the side. So divided by 0.472 moles total, divided by 0.472 moles total, divided by 0.472 moles total. Now, so far, we've done a lot, but it's nothing that's difficult. It's just that because we have to do it 3 times, that's the only thing, is it just takes a little bit longer. But we really haven't done anything that was really hard. We changed grams to moles, that's it. And then all we're doing is we totaled it and we're finding the fraction. We divided by the total, that's it. So let's divide this and find out what we get. On the first one, we get 0.477. On the second one, we get 0.424. And on the third one, we get 0.0989. What are the units of this? What are the units?
Nothing.
No units. Fractions don't have units. What you would call this is you would actually call this chi. That's your chi. and chi is a fraction, and you don't have units like percent, for example, or fractions, you don't have a unit because they just cancel out, okay? So now we have that very last step. The final step is, once you know your fraction, just like we did on the page before, now you know what the fraction is, what do you multiply by? Why? The total pressure. Perfect. Now the third step, so we'll go through the steps, what we did here. Now all we're going to do is we're going to multiply by the total pressure because this is our chi. And we set up on top, if you know your chi, all you need to do is multiply by the total pressure, and that's going to give you the partial pressure of each gas. So what is our total? Well, we circled it right there. So we're just going to multiply by 200 millimeters of mercury, and multiply this one by 200 millimeters of mercury, and do the same thing for the last one, times 200 millimeters of mercury. Again, it's not difficult, it's just that it's a lot to do, but it's just nothing, there's nothing that's really difficult to do. So in this case, we're going to get 95.4. Now what are the units? Millimeters of mercury. Good, because no units times millimeters of mercury gives you millimeters of mercury. And the second one, we'll get 84.8 millimeters of mercury. And the last one, we get 19.8 millimeters of mercury. Okay, so just as a recap, step number one, let's just go back up and fill this in. Step number one, all we did was we converted grams to change grams to moles. That was it. That was step number one. Step number two was we had to find what? Find chi. How do you find chi? Chi is equal to moles of X divided by your total moles. Okay? That was our second step. Our third step, once you know your chi, what do you multiply chi by? Your total pressure. And once you do that, you're going to get your final answer. Okay? So let's come back up to the top here and let's just fill this in. So step number one we said was change grams to moles. Step number two, once you're in moles, you're going to find chi. And chi is equal to moles of X over your total moles. And I do want you to write down that you have to add up all of your moles from each one. You have to add up the moles from each one. People will try, like for example, you might have a multiple choice question that says, what's the partial pressure of SO2? And they try to do it without figuring out the moles of each one. You have to figure out the moles of each one first. And step number three, in order to find out your partial pressure of your gas, you're going to take your chi that you just found here, which is your mole fraction, and you're simply going to multiply it by the total pressure. And the total pressure has to be given to you in the problem. Okay, it must be given to you. And in parentheses over here, I'm just going to say, if you're given percent, then all you have to do is shift your decimal 2 loops back. Okay, shift your decimal 2 loops back, and then you can use that as your chi. That is your chi. Okay? All right, and that's basically it for Dalton's law of partial pressure.